Okay, so hello everyone. My name is Kunal and I'm your mathematics tutor and we are doing actually differential equation and today is our lecture number third. So let me recap the thing कि हमने क्या क्या अभी तक cover कर चुके हैं. So we actually know about the degree of order and degree of D. Then we know how to form differential equation and then we know the solution of differential equation. एंड जिसमें अपन पढ़ रहे थे मेथड ऑफ डिफरेंशियल इक्वेशन, मेथड ऑफ फाइंडिंग द डिफरेंशियल इक्वेशन, मेथड ऑफ फाइंडिंग द सॉल्यूशन ऑफ डिफरेंशियल इक्वेशन, राइट. एंड इसमें हमने पहला मेथड पढ़ लिया था विच इज लाइक वेरिएबल सेपरेबल, है ना. तो वेरिएबल सेपरेबल हमने कर लिया था कवर, जिसमें ये तभी अप्लाई करते हैं वी यूज वेरिएबल सेपरेबल मेथड व्हेन ऑर्डर एंड डिग्री ऑफ differential equation must be 1, right? So let us start with some problem on this and then we will move to the next method, which is actually, let me write it here, homogeneous equation. Okay, so let me try to solve some problem, okay, and then we will discuss about the new property. So let me take first problem. So question number 1, it is something like x into 1 plus y square or dx is equal to y 1 plus x square into dy, right? So and one more thing is here given, y1 is equal to 0. This is actually given. Okay, so you have to find the solution of the particular solution, because the constant value we can determine. So actually we have to find the particular solution of this differential equation. Okay, so first you have to first you have to find the order and the degree of the differential equation. So it's clearly written from here. We can write here like dy by dx is nothing but x into basically 1 plus y square divided by y into 1 plus x square. I think these were clear to you, right? So we can write into this form, right? And now what you have to do, so here it's clear like order and degree of differential equation. Given differential equation is 1, so so we can apply variable separable method. So we can apply variable separable method, and so we can apply the variable separable method. So let's apply here. So what we will get, let me write it here. We can write it as dy, and there will be rearrange it. So y dy by 1 plus y square and integrate both sides, and there will be x by 1 plus x square and dx. Okay, so now do nothing, just multiply 2 on both sides. So if this is our f, so this is our df, and if this is our g, so this is our dg. So integrate both sides, what we will get, this is actually the nothing but the integration of 1 ln. So there will be get ln 1 plus but we have to do half also both sides, and we can remove it as well, so nothing to worry about. So what we will get, we'll get 1 by 2 ln 1 plus x square from there, and there will be get half ln 1 plus y square into some constant. And now we have to find the value of constant. So take it as, because we have to find the particular solution now. So and there is a value given which is actually y0 is equal to 1, y1 is equal to 0 is given. So we can determine the k value from here. Okay, so let's try to find the value. Okay, so here will be actually given when x is equal to 1, actually the y is equal to 0. So therefore imply 1 by, just put the value of x as 1 and y as 0. So ln2 is equal to half of, and there will be 0. So plus k. So the value of k will be nothing but half of ln2. So this is our constant value at okay. Now what you have to do from equation 1, this is our equation number 1. So from equation 1, what we will get? Half of ln 1 plus x square is equal to half of ln 1 plus y square plus half of ln 2. So we can remove ln, basically the half from all side, and what we will get? We will get 1 plus x square by applying the simple logarithmic property, which will be multiplied to here, will be get 2 plus 1, 2y square, right? And on solving, what we get? X square minus 2y square is equal to 1. So this is our solution. So what I am getting here, x square minus 2y square is equal to 1 is the solution of this differential equation. Is the particular solution. Let me raise it and write it again. Is the particular solution. Is the particular solution of our differential equation. This is nothing but x into 1 plus y square is equal to y into 1 plus x square. Okay, so इसकी जो फाइनल पर्टिकुलर सोल्यूशन है वो क्या है? x square minus 2y square is equal to. So I hope this will be clear to you. Now we are gonna learn a new things, which is actually, let me write it here. Okay. So the things is reducible to variable separable. Okay, so reducible to variable separable का मतलब क्या है? So let me try to elaborate you. So it will be nothing but dy by dx is equal to f of ax plus by plus c. So if our dy by dx something is given like a function of ax plus by plus c. So actually what we have to do, we can reduce it to form of variable separable, right? So how can we do? Let's see. So what do you have to do? Just let ax plus by plus c is equal to t. Ax plus by plus c is equal to, just assume as t. And then our equation will change to a variable separable. Okay. Then equation will change to variable separable. Because what is the form of variable separable? The form of variable separable will be something dy by dx is equal to something fx by gy or fy by gx, right? यही तो फॉर्म होता है ना, fy by gx something. And but there is something given in the form of ax plus by plus c. तो ये तो फॉर्म होती नहीं है ना वेरिएबल सेपरेबल की. So we have to actually convert these form into variable separable method, है ना? So let's okay, let's see. So what you have to do, you have to just write ax plus by plus c, whatever it is, add some t. Okay, then our equation will change to a variable separable. And just differentiate it. So what we will get? We will get a plus, actually we are differentiating with respect to x, both sides. Okay, so when we differentiate, what we will get? A plus b dy by dx, and the c will be 0 because it will be constant, is equal to dt by dx. That's imply the dy by dx is equal to just we have to write dy by dx, है ना? So what we will get? First we will get dt by dx minus a, and then there will be 1 by b. And so this is our actually dy by dx, which we have to substitute. Okay, so this thing we have to do. Like let me tell you again what I'm doing here. Like, let us suppose this is actually what is the form of variable separable. So actually, this is the form of variable separable, right? And if our given differential equation is of order one and degree one, so we can apply the variable separable. But if it is not in form of exact applicable variable separable, so what we have to do first, we have to whatever given inside the function, take it as t, differentiate it, and try to reduce it to variable separable form. But the noted thing is, uh, the order and degree of the differential equation must be 1. Okay, I hope it will be clear to all of you. So let me show you by some example. So our first example is, let me take it here. So the question 1, which is something like dy by dx is equal to x plus y whole square. Look at here. In general, our our actually differential equation of order 1 and degree 1, where variable separable is applicable, is of the form like dy by dx is equal to something like fx by gy, or something gx by fy, gy by fx, है ना? But there is not like that form. So what we have to do, मैंने यहाँ पे क्या करा, इसकी मेथड जो है, actually this is the method. So मैंने क्या करा, I just take whatever is the function as t. So what I have to do here is, I have to just take x plus y, because this is our something function of that format, right? So I have to just substitute x plus y is equal to t and differentiate it with respect to x. So differentiate it with respect to x. So what we will get from here, 1 plus dy by dx is equal to dt by dx. And then what we will get the value of dy by dx as. So here we will get dt by dx minus 1. Okay, and now go through the original differential equation. So it will be something like dy by dx is equal to x plus y whole square. Right? So what I'm gonna do here is, I just substitute dy by dx in place of here dt by dx minus 1, which is as equal to, and x plus y as is our t square. Right? So we can do here, and then we will get dt by dx is equal to 1 plus t square. And this is actually the form of uh, variable separable method, and here order and the degree of differential equation is 1, right? Because it is actually first derivative, and on the first derivative it has power also 1. So its order and degree will be 1. So it will be like dt by 1 plus t square is equal to dx, and now integrated both sides. So what we will get from here is, this is what is the integration of 1 by 1 plus x square? This is like tan inverse of t. I hope you all know this. Okay, so let me write it here. Tan inverse of t is equal to x plus some constant, right? So because here we will get the general equation, because no particular solution, because here the value of function is not given. If any one value of function will be given, so we will get the particular solution. But here we will get the general solution, because there is function value is not given. Okay. Okay. So here we will get t is equal to tan of x plus y, x plus c, where t is our nothing but, what is t actually, our x plus y. So we can substitute here. So now substitute the value of t is equal to x plus y here. So what we will get here, we will get x plus y is equal to tan of x plus c. So actually, therefore, x plus y is equal to, this is our solution. This is our general solution. So x plus y is equal to tan of x plus c is the general solution for the differential equation. कौन सी differential equation है अपनी? dy by dx is equal to x plus y whole square. Okay, so this is our not a particular solution because limit is not given here. So actually this is our general solution. Okay, so this is the method which is actually known as reducible to variable separable. तो ये तब अप्लाई करते हैं जब अपनी ऑर्डर एंड डिग्री ऑफ डिफरेंशियल इक्वेशन 1 हो, बट वो एग्जैक्ट फॉर्मेट में नहीं हो जिस फॉर्मेट में अपन वेरिएबल सेपरेबल को अप्लाई कर सकते हैं. Then we do this method, which is also known by reducible to variable separable. We just substitute the value of function as t and just differentiate it and calculate the value of dy by dx and try to substitute in original original differential equation, and then we will calculate the and then actually that form will be reducible to variable separable, and then we can easily calculate the value or basically the solution of the differential equation. So let me take the one more example so it will be clear to you. And then we will move to the homogeneous differential equation, which is actually important. So let me take one more example, which is something look like, okay, that's basically the last example on reducible to variable separable because it's easy. Okay, so let me take it. So here the question is, dy by dx is equal to x plus 2y plus 1 whole square. Okay, so what we have to do? Actually, we have to this differential equation is of order and degree 1. So we can apply variable separable method here, but it's not in the format of the variable separable method. So what I have to do? I have to just substitute the function value as t. So we will write here x plus 2y plus 1 is equal to t, and just differentiate it with respect to x. Differentiate it with respect to x. So what we'll get here from here? 1 plus 2 dy by dx is equal to dt by dx. That's imply what we will get here. We will get dy by dx is equal to 1 by 2 dt by dx minus 1. Now, what you have to do, just substitute the value of dy by dx in the original differential equation. So now from original differential equation, what we will get? Actually, 1 by 2 dt by dx minus 1 is equal to t square. And now just try to solve it here. First, try to rearrange. So it will be dt by dx minus 1 is equal to 2t square. So the dt by dx is nothing but 2t square plus 1. So dt by 2t square plus 1 is equal to dx. Now देखो, ये भी एक differential equation है and its order and degree is 2. 1. So here we can also apply the variable separable method, and it is of the form which satisfy the form of the variable separable. So what I'm going to do here is just try to integrate the both sides. So what we will get here? Let me write here. So what is the integration of 1 by basically t square plus 1. So we can take common. First try to make the coefficient of x square as 1. Okay, so try to make it. So when we'll take the common, we will get t square plus 1 by root 2 with basically 1 by root 2 whole square. We can write into this form, and there will be dt and there will be 1 by 2. And we know that the integration of root and 1 by a square plus x square is nothing but 1 by a tan inverse of x by a. So it will be like 1 by a tan inverse of x by a, which is as equal to x plus some constant. So here we will get root 2x plus c is equal to root 2x root 2x naught. There will be, I changed the variable actually, है ना? This is the blunder, root 2t. So root 2t actually is equal to tan of root 2x plus c. Now, what is the value of t? So let's try to substitute here the value of t here. So substitute again the value of t is equal to what we actually substitute here will be x plus 2y plus 1. So what we will get? We'll get root 2 x plus y plus 1 x plus 2y plus 1 is equal to tan of root under 2x plus some constant k, where k is equal to root under 2c. So this is actually the general solution of our given differential equation. General solution, not particular solution, because the value of function is not given. Okay, so the solution will be general. I hope this thing will be clear to you. तो यहाँ तक हमने देखा कि when the order and the degree of the differential equation is 1, so we can find its general and particular solution by using variable separable method. और अगर डिग्री एक और ऑर्डर एक है बट वेरिएबल सेपरेबल की फॉर्म में नहीं है, सो वी टुडे इज लर्न दी रिड्यूसिबल टू वेरिएबल सेपरेबल एंड उस पे 2 प्रॉब्लम हमने कर लिया, उसकी इम्प्लीमेंटेशन भी सीख गए, है ना, लाइक हाउ टू इम्प्लीमेंट एंड ऑल. कुछ भी नहीं करना होता है, जो भी अपना डिवाइड बाय dx दिया हुआ है वो बस फंक्शन के फॉर्म में लिखी होती है. सो यू हैव टू जस्ट डिफरेंशिएट those function by substituting the value t and get the value of dy by dx in the term of dt by dx whatever, and then try to solve because it's in the form of now applicable of variable separable, है ना. So अब आप लगा सकते हो and it will be solvable easily. Okay, so let's try to move to the new topic which is actually known as homogeneous differential equation. So let's start. So what is actually homogeneous differential equation? So let me write first a definition and all, and then we know how to solve, and then we know how to find the solution of differential equation using homogeneous differential equation. Okay. So let's start. Let me give the heading of the topic, which is actually homogeneous डिफरेंशियल इक्वेशन. अगर आपने एक चीज नोटिस करा होगा तो यहाँ पे डिफरेंशिएशन और इंटीग्रेशन का मिक्सचर ही है बस डिफरेंशियल इक्वेशन, है ना. बस हमें उसकी सॉल्यूशन चाहिए होती है, होमोजेनियस डिफरेंशियल इक्वेशन. सो लेट्स स्टार्ट आवर टॉपिक. First let me write it definition. So what it is actually, so a differential equation of the type dy by dx is equal to f of xy g of xy where fxy and gxy are the actually homogeneous function, are the actually homogeneous function of x and y of same degree. अब आपको तो पता होगा कि होमोजेनियस फंक्शन की डेफिनेशन क्या होती है, अगर नहीं पता तो लेट मी राइट इट हियर. सो एक्चुअली होमोजेनियस की जो डेफिनेशन होती है वो ये होता है कि होमोजेनियस तभी होता है इफ एफ ऑफ लैम्डा एक्स और लैम्डा वाई, अगर लैम्डा इंसर्ट कर देते उसमें, so it will be equal to lambda to the power n f of xy where n is the degree of, let me write it in a clear way, where n is degree. Okay, so let me try to elaborate it again. देखो होता क्या है कि एक डिफरेंशियल इक्वेशन होगी which is of the type like dy by dx is equal to something, एक दो वेरिएबल की फंक्शंस लिखी होंगी विच इज इन मोस्टली इन द फॉर्म ऑफ एक्स एंड वाई एंड उसके डिनोमिनेटर में भी एक दो वेरिएबल की फंक्शन लिखी होगी विच इज मोस्टली यूज एज एक्स एंड वाई. सो हाउ टू सॉल्व दिस प्रॉब्लम? सो फर्स्ट द जो भी न्यूमरेटर एंड डिनोमिनेटर में फंक्शन है वो एक होमोजीनियस फंक्शन होनी चाहिए विथ इन एक्स एंड वाई, मतलब सेम डिग्री की होनी चाहिए. ठीक है. Then what we can do, then this is known as the homogeneous differential equation. Okay. Now, what is the method to solve differential equation? What is the method? Tell me. So the method is, let me write it here. Actually, to solve such a differential equation, okay, to solve such differential equation, just substitute y by x is equal to t. Okay, so when we substitute the y by x is equal to t, what we will get? Basically, y is equal to xt. Let me write it here in a clear way. So y is equal to xt, right? And when we differentiate it with respect to x, differentiate both sides with respect to x. So what we will get from that? We'll get dy by dx is equal to, here we have to apply the product rule, right? Because this is of the form u, this is of the form v. So what I have to do? First, I have to differentiate x. So we'll get t and then plus, and we have to differentiate this term. So what we'll get? X dt by dx. I hope this thing will be clear to you, and then solve. So this is the actually method to solve this homogeneous equation. देखो कभी भी homogeneous equation का पहले मतलब क्या होता है वो समझ लो. तो homogeneous equation जिसमें कि x and y पे पावर क्या हो ना, डिग्री सेम हो. ठीक है. ओवरऑल डिग्री जो है वो हमारे पास क्या आनी चाहिए? सेम आनी चाहिए. And what is the process to solve such a homogeneous differential equation? So the method is कि just substitute y is equal to xt or y by x is equal to t. So when you substitute like y is equal to xt or y by x is equal to t, so what actually you get? So you get y is equal to xt and then try to differentiate both sides with respect to x. So what we will get here? Look at here. So what we will get here? Actually, when we differentiate both sides with respect to x, so we will get dy by dx is equal to, and now there is x and t term, so we have to apply the product rule here. So first differentiate x and take t as a constant, so it will be t plus. I hope you all know like how to differentiate. Okay, so I have I'm just explaining. अगर किसी को समझने में दिक्कत है, so it will be like x into dt by dx, and then you have to proceed and solve. Okay, so let me give you some example like how to implement and to find the solution of the homogeneous differential equation. So let's start. So let me write it here. We have a first problem is something. Example one is something written as, look at here, dy by dx is equal to y square minus x square by 2xy. Look at here. This is of the formula of dy by dx, and the order of the numerator is 2 and order of the denominator is also 2. Right. So what I have to do? I have to do nothing, just y by x, and we have to substitute as t. So first try to make your y by x form. Okay. So do some manipulation here. Do some manipulation. क्या करनी है? बस करनी कुछ नहीं है. Divide and multiply by x square. Multiply and divide by x square. So when we do that, what we'll get? We'll get dy by dx is equal to y by x whole square minus 1 divided by 2 and y by x. Okay, and now basically now you have to just follow the स्टेप सो अपनी स्टेप्स को देखते हैं एक बारी. सो हमें क्या करनी है, जस्ट हमें y इक्वल टू एक्स टी पुट कर देना है. सो सब्स्टिट्यूट y is equal to xt and then what you have to do, differentiate both side with respect to, किसके रिस्पेक्ट में करनी है, x के. so what we'll get dy by dx is equal to t plus x dt by dx. So here we will get the value of dy by dx and what is actually is equal to, it is equal to t plus x now from our original differential equation. It will be equal to t plus x dt by dx. Actually is equal to, यहाँ पे क्या आ गया, y by x की जगह हमने t पुट करा है ना, it's also imply y by x is equal to t. So let me write it here. So it will be equal to t square minus 1 divided by 2 into t. Now just do some rearrangement and try to find its value. So what you have to do here, just take t from right hand side, left hand side to right hand side. So we'll get x dt by dx is equal to t square minus 1 by 2t minus t. So it will be 2t t square minus 1 will be minus 2t square. So it will be equal to minus t square minus 1 by 2t. So okay, this thing we will get it from here. And now what you have to do here is, let me write it here, cons, then, okay. So here we'll get x dt by dx is equal to minus t square minus 1 by 2t. And here we will get dt, so we'll take minus outside, so we'll get 2t by 1 plus t square. I just rearranging the name. 1 plus t square is equal to dx by x. Now what you have to do, you have to just integrate both sides. So when I integrate it, so what I am getting is, if this is our f function, so this is our df function. So nothing but minus of ln 1 plus t square is equal to, this is, its integration will be easy, right? Ln of x and put some constant here. I hope this thing will be clear to you. And if this constant को अपन अगर किस format में ले लेते हैं, let us suppose this is of the format of like ln something k. So it will be, can be like this, our constant will be some form of ln c. So we can write now like minus of ln 1 plus t square is equal to something like ln x by c, because it's in the form of, sorry, ln xc. Let me write it in a clear way. We can write here, okay, we can write here ln sc. Now, remove the from the both sides. So what we'll get? We'll get 1 by t square is equal to xc. And now try to substitute. The value of t square. The value of, actually देखो हमने क्या करा था, हमने y by x को t रखा था, and यहाँ पे हमें t को हटाना होगा. So now substitute the value of t is equal to 1 by x. So what we will get from here? We will get y square by x square is equal to x into some constant. So when we solve that, what we will get here? Let me try to see. So here we will get x square by x square plus y square is equal to xc. So this will be get cancelled. So what we will get? We'll get x is equal to x by some constant is equal to x square plus y square. So this is our actually the general solution, because the value of the function is not given, so we can't calculate the exact value, right? Particular solution नहीं आएगा यहाँ पे आएगा अपना general solution. I hope it will be clear to all of you. मैंने बस करा क्या? So I just follow this step. So if you stuck at anywhere, so you have to just follow this step to get out from there. So okay, so what I'm just trying to say you, कि like यहाँ पे देखो ये एक डिफरेंशियल इक्वेशन है, ठीक है, और इसकी ऑर्डर एंड डिग्री 1 है, और ये एक ऐसा फंक्शन के इक्वल है जिसकी न्यूमरेटर एंड डिनोमिनेटर की जो डिग्रीज है, डिग्रीज ऑफ पॉलिनोमियल है, वो सेम है, तो एक्चुअली ये होमोजीनियस है एक्स एंड वाई के रिस्पेक्ट में. So just what you have to do, you have to just substitute y is equal to xt here, and you have to just solve. Uh, no, first you have to get the value of dy by dx in term of dt by dx, and then what you have to do, you have to just write the uh, each and every single term in the form of x and y, and you have to just and you just get the solution. Okay, so okay, now let's move on to the next problem, which is something like let me write it here. क्योंकि देखो एक एक दो प्रॉब्लम प्रैक्टिस कर लेने से हो क्या जाता है ना कि चीजें क्लियर हो जाती है. तो लेट मी टेक वन मोर एग्जांपल जिससे आपका ये ये चीजें कॉन्सेप्ट क्लियर हो, व्हिच इज ऑन होमोजेनियस इक्वेशन. So the second problem is something like example 2 is actually is equal to x into cos of y by x, cos of y by x into dy by dx is equal to y into cos y by x plus x. So you have to solve this equation. So first, what you have to do, first you have to write it into a homogeneous equation, right? So let me try to write here. So it will be something like equal to, let me write it here. So it's something equal to y dy by dx. देखो अगर मैं यहाँ पे देखूँ होमोजेनियस इक्वेशन में तो dy by dx एक साइड है and the rest of the term on the right hand side. Whatever the function is, I don't care right now. I just do one thing कि मैं dy by dx को लेफ्ट हैंड साइड रख रहा हूँ, बाकी जो भी फंक्शन है उसको अपन क्या कर दे रहे हैं राइट साइड में ट्रांसफर कर दे रहे हैं. सो जस्ट डू दैट. सो लेट मी डू इट हियर. सो dy by dx is equal to, so dy by dx is equal to what we can write it here. We can write y cos y by x plus x and divided by x cos y by x, right? We can write it into this form. We can. And now what you have to do? Our dy by dx is equal to, first try to simplify it. So what we'll get? We'll get y by x plus x got cancelled. So we'll get cos of y by x. So now what you have to do? You have to just substitute the y is equal to xt, and now try to differentiate it with respect to x. So what we will get from here, we'll get dy by dx is equal to t plus x dt by dx. I know. So, okay. So the dy by dx is equal to t plus x dt by dx. So now what you have, so हमें मिल गया ना value. So we get the value now from original differential equation. Now from original differential equation. So what we will get from here is we have to just substitute the value of dy by dx as t plus x dt by dx. So just write it here. So we'll get t plus x dt by dx is equal to we actually substitute the y by x is equal to t here. So it will be something like t plus 1 by cos t. So we can write it into a sec t, but okay, let's go to the above equation. So this and this get cancelled. And then what we'll get x of dt by dx is equal to 1 by cos t. Okay. And now what you have to do? Just dx by x. Just I'm rearranging here. So what we'll get here? Cos t dt. Just try to integrate the both sides. So what is the integration of cos t? It will be like sin t. Sin t is equal to the integration of it will be ln plus x plus some constant. Now just substitute the value of t is equal to y by x, because हमने पहले वही रखा है ना. देखो यहाँ पे t is equal to y by x रख दो. So what we will get here? We will get sine of y by x is equal to ln mod x plus some constant. So this is the actually the general solution. So this is actually the general solution for the differential equation. ये आपको लिखनी होगी लास्ट में. लेट मी राइट इट हियर. वेट, वरना स्टेप मार्किंग पे मार्क्स कट जाते हैं. एक्चुअली बोर्ड वगैरह में काट ही लेते हैं. ये बस सॉल्व करके नहीं लिख छोड़ना होता है, हमें इस पे लिखनी भी होती है आगे. So we will get this. So let me write it here. So sine of y by x is equal to ln mod x plus some constant k is the general solution. Is the k is the general solution for किसके लिए? तो for x for differential equation x into cos y by x dot dy by dx y cos y by x. Okay, so these are the things that we have to do. तो हमें ये लास्ट में लिखनी होती है. सो देखो हमने यहाँ पे क्या सीखा आज. सो लेट मी रिकैप वन थिंग, देन वी मूव टू द नेक्स्ट टॉपिक. सो हमने आज क्या सीखा? हमने देखा सबसे पहले रिड्यूसिबल टू वेरिएबल सेपरेबल, देन होमोजेनियस डिफरेंशियल इक्वेशन के बारे में हमने जाना, एंड देन उस पर हमने मेथड देखे और उस पर दो प्रॉब्लम करी. एक प्रॉब्लम पर्टिकुलर सोल्यूशन वाली भी करा ही देता हूँ, क्योंकि यहाँ देखो हमने दो प्रॉब्लम करी, दोनों में जनरल सोल्यूशन निकाला, राइट? So let's do one problem on particular solution. You have to actually find. So let me write it here. Let's find the particular solution for 2x square y dash. And you all know that what is y dash is, right? So I'm not gonna write it here. So 2xy plus y square is equal to 0. So it will be equal to y is equal to e. Okay. So now on we can okay. So you have to find the particular solution for this differential equation. So what you have to do, just you have to actually take it as homework and try to solve. But I am gonna give you some hint here. You have to substitute y is equal to tx. So we will get the dy by dx as nothing but t plus x dt by dx, right? And when we solve this, so let me try to solve it here. So my suggestion is to pause the video, and so my suggestion is to pause the video and try to solve it by own, and then watch the solution. Am I correct or wrong? Like you are like you got the right answer or wrong answer. So let me try to solve it here. So what we will get from here is first try to rearrange it. So we will get like a minus of 2 dt by t square is equal to integration of dx by x. And now when you integrate this, we all know the integration of 1 by t square is nothing but 2 by t. So we will get 2 by t is equal to ln of x plus some constant. And now what you have to do, you have to just substitute the limit value, right? We have something given of y is equal to e. So put x is equal to e here. So first try to substitute here by x and y. So we'll get 2x by y is equal to ln x plus c. And then substitute x is equal to e. So we will get y is equal to e. So just write it here. So you will get 2 and ln e value will be c. So c value will be 1. So the particular solution, for the differential equation, whatever written, 2x square y dash minus 2x y plus y square is equal to 0 at y is equal to e is क्या है हमारे पास आया है y into ln x e is equal to 2x. ओके, सो ये आज हमने सीखा होमोजेनियस इक्वेशन को कैसे सॉल्व करते हैं. ओके, सो दैट्स ऑल फॉर टुडेज गाइस. इन नेक्स्ट क्लास वी आर गोना रीड रिड्यूसिबल. इसके काफी सारे केसेस हैं. सो यू हैव कल की क्लास मेजरली थ्योरी से ही होगी, क्योंकि कल कल की क्लास में उतनी इम्प्लीमेंटेशन सीखेंगे नहीं. कल की क्लास में मेजरली थ्योरी होगी. इट विल बी लाइक रिड्यूसिबल टू homogeneous equation and try to practice question on variable separable method and the homogeneous differential equation. Okay, so these were actually quite helpful in J mains kind of thing. Okay, so majorly variable separable से आती है and या फिर linear differential equations आता है. So we will actually जो linear differential equation है, so अपन वो आगे सीखेंगे. It will be in majorly in sixth and seventh lecture. But first we have to clear our basic regarding variable separable and the homogeneous differential equation. Okay, so that's all for today. Thank you.